through its meltability in mouth or stretch properties in pizza. Cheese is one of the milk products that is cherished for its texture, aroma, and flavor. We have different types of cheese that can be obtained by minor changes to processing parameters or steps. So let's take a look at how this yummy product is made from milk. Cheese can be formed in one of the two ways, either via enzymatic coagulation or acid coagulation. I would first like to discuss enzymatic coagulation. So, enzymatic coagulation, we have milk, which is rich in proteins. About 80% of milk proteins, they are caseins. So, this casein can be present either in its alpha form, beta form, or kappa form. So, it is this kappa casein which is responsible for conferring stability to our colloid, which is milk. So, when we add an enzyme called as rennet, it cleaves kappa casein at a specific location. So, the bond, the peptide bond, which is present between 105th amino acid and 106th amino acid, it is broken. Most often, these amino acids are phenylalanine and methionine. When amide bond is broken, we have two parts that are formed. The first part is rich in hydrophilic group and is called as caseino macropeptide. It is during cheese making process, this part is washed away in whey. Second part is called as para-kappa casein, which is rich in hydrophobic groups. Once enough kappa casein has already been disintegrated, there is tendency of hydrophobic molecules to come together via hydrophobic bonding in order to reduce the free energy of the system. So they form a three-dimensional gel-like network called as curd, which on synosis yields the structure of cheese that we all know. Rennet used for producing cheese using enzymatic coagulation is made using recombinant DNA technology. The second one is acid-induced coagulation. So one characteristic property of proteins is that they become insoluble at their isoelectric point. So isoelectric point is that point wherein protein possesses no net charge. They do have charge, but the sum of positive charges is equal to sum of negative charges, meaning there is no net charge on protein. Milk has a pH of 6.6 and casein is known to have an isoelectric point of 4.6. So when we add acid, like acetic acid in the form of vinegar, citric acid, or at industrially they make use of glucano delta-lactone, it reduces the pH of milk from 6.6 gradually to 4.6. As you near the isoelectric point of proteins, that is casein, there is reduction in electrostatic repulsion, meaning like charges do not repel each other anymore. Instead, they come together, especially the hydrophobic groups, they come together to form a three-dimensional gel-like network called as curd, which on synosis yields our cheese. Synosis is nothing but it is removal of extra water from the curd in order to form the structure of cheese. Now, when we make use of enzymatic coagulation, certain metal ions like calcium or magnesium is added in order to reduce the time required for gel formation. One interesting fact that I would like to highlight here is the caseino macropeptide that is derived during enzymatic coagulation. It is known to exhibit anti-cardiogenic activity as it inhibits growth of several oral microbes, especially bacteria, that are responsible for formation of dental plaque. Thank you for staying with me through the video. In case you have any queries, please feel free to put them in the comment section and I'll get back at the earliest.